Our next function in our library of functions from section 3.4 is the cube function. So we have some suggested points to plug in here for x. Let's calculate this one out. Y equals -2 cubed. We get -8, so when x is -2, y is -8. Y equals -1 cubed. So -1 gives us -1. Of course, 0 cubed would be 0, 1 cubed would be 1, 2 cubed would be 8. So we have -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So our cube starts up here in the first quadrant, comes down, passes through the origin. Okay, so when we see this shape starting up here on the right and coming down on the left like that, that brings to mind the cube function. Let's look at the square root function. Now, we've been suggested -4, but can we take the square root of -4 in the real number system? No. So that's not going to be a real solution. Can we take the square root of -1? No, we can't. This would be non-real, and we're not graphing that. This would be non-real. Okay, well, can we take 0? The square root of 0? Yes. Square root of 1? Yes. Square root of 4? Yes. Okay, so we have our domain is not all real numbers here. For the first 3, we've seen all real numbers, but now all of a sudden our domain is not all real numbers because we have this radical of even index. Okay, so we'll start with 0, 0, 1, 1, 4, 2, and what happens is we get this graph that goes just straight through the first quadrant. X has to be positive and y is positive, except when they're both 0. This is our most basic graph of a square root function. Okay, so let's go on to the cube root function. We saw the cube function, but now let's see the cube root function. All right, now we have the cube root where it's suggested we put in -8. Can we take the cube root of -8? We certainly can. It's an odd root, so y is the cube root of -8. Use your calculator if you want to be sure, but that's -2. And the cube root of -1 would be -1. The cube root of 0 would be 0. The cube root of 1 would be 1. And the cube root of 8 would be 2. So let's see what the cube root function looks like. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So remember the cube function came down like this through the origin, but now the cube root function looks like this in its most basic form. Okay, let's look at the reciprocal function. Now again, this one all real numbers, but this one, because that was an odd root, not even, we have a variable in the denominator. So we have to exclude from the domain all values of the variable that make the denominator 0. What would that be? Yeah, it's 0. So we know we can't use that, right? We're not going to put 1 over 0, but we can do all of the rest, right? So 1 over -2 would just be -1/2, right? 1 over -1, -1. 1 over -0.5, how many times will -1/2 go into 1? It would go in there, what, -2 times? And 1 divided by half would be +2. 1 divided by 1, and 1 over 2 would be 1/2. Okay, let's see what this looks like. We have -2, -1/2. I'm going to have to just kind of guess where that -1/2 would be. -1, -1, and -1/2, -2. So what we're seeing for the first 3 here is a piece that comes and skims along the x-axis, curves through here, and goes down the y-axis. What happens here? At a half, we're up here at 2. At 1, we're at 1. And at 2, we're at a half. So we have a second piece here. So this graph is actually in 2 pieces, and x can never be 0. That's our reciprocal. Okay, 2 more in our library that we want to look at today. The absolute value function. All right, all real numbers, right? Because we don't have a variable in the denominator or a variable under a radical of even index. So when you take the absolute value of -2, what do you get? 2, absolute value of -1, 1, absolute value of 0, 0, absolute value of 1, 1, absolute value of 2 is 2. -2, +2, -1, +1, 0, 0, 1, 1, 2, 2. And what we get here is through the first quadrant, starting at 0, we have this 45-degree angle line, and going through the second quadrant, where x is negative, but y is positive, because when you take the absolute value of a negative number, you get a positive. There's our absolute value function. Finally, our last in the library of functions, f of x equals b, where b is a real number. So what is this when we let me replace that f of x with y. Now that should look familiar. What kind of line is that? Well, it's a horizontal line, right? And so that's what they're showing here. So for example, let's say that this was f of x equals 2 or y equals 2. Then that would be, at the point right there, would be the point 0, 2. And this would be our horizontal line. If you want an example, this is just a generic diagram, but that would be our example. It's called the constant function because y is a constant.